Today, Eliza and Jeremy are building a custom console, dash, and cowl in their Prerunner Ranger. And they're building a mount to carry both spares. Then they'll get their new digital gauges installed. It's all right here on XOR.
Hey guys, welcome to XOR. Now that we've got most of our roll cage complete, it is time to start working on the interior. And that begins with a center console and a shifter mount. The first piece is the lower bar that will serve as a mounting point for my console. It also connects from one B-pillar post to the other. Let's get the other bars in, fit those up. These are the structural tubes of the console itself. We're mocking up the driver's seat in place so we know how wide our console can be. These connect from my lower bar to the lower dash bar. All right, let me cover up the seat so we don't ruin it. The passenger side bar is placed about 6 inches from the first bar. All right, get the seat out of here so we can continue plugging away. Thank you. With the seat out of the way, now I can tack the console tubes to our lower crossbar. This thick plate of steel will serve as the mount for our race shifter. Alright, that's where the shifter goes. These small crossed plates will serve as both reinforcement and mounting points for the thin gauge aluminum that will cover our console. Thank you, Jeremy. This is 20 gauge aluminum and it can be easily manipulated into the shape we want. Since I'm not ready to do the final install, I'm using Clecos to hold this piece in place. Plus, they save the soft aluminum from wear and tear when we take it back out to finish the interior, before installing it one last time. Then it'll be permanently screwed in place. If you have never used Clecos, they expand on the far side of the workpiece and then draw and clamp them together while maintaining the desired alignment and preventing distortion of the pieces. They should fit snugly in their holes to prevent shifting of the workpiece as I shape the aluminum. Another benefit is that they can maintain the alignment of the drilled fastener holes that do not have Clecos in them. All right, done.
Up next, we'll get our dash panel and cowl installed. And later, we'll install our new digital dash.
Hey guys, welcome back to XOR. With most of our center console completed, now it's time to start working on the dash. And that starts with a little bit of measuring and some cutting of angle iron. I need a vertical reference to measure the dash bracket that will push the bottom of our dash panel outward. These brackets are also cut out of angle iron. This long piece serves as the bottom mounting point and support for our dash panel. Okay, fits pretty good on my side. Yours does too. Cool. I'm using a level to make sure the two center dash mounting points are parallel with our panel. And the magnets built into the level help keep these two small mounting plates in place as they get tacked. And the same goes for the two outside mounts. Jeremy, can you hand me the dash? Thank you. Ooh, that's gonna work out great. I'm using a square to mark my drill holes on the panel. This keeps me in line with the angle iron mounting plates now behind the dash. A small amount of tape wrapped around the drill bit helps protect the panel from scratches that would be left by the impact of the chuck jaws. I'm taking the same approach for mounting the cowl, angle iron brackets for support. The cowl will serve to keep rocks and debris out of the cabin behind the dash. It will also protect our racing gauge cluster that we are going to install. The cowl is made from the same 20 gauge aluminum that our console cover is made of. And since we don't know just how many times this cowl will need to come off and go back on during the build, like the console, we are going to temporarily secure it in place with Clecos. Since Clecos are a blind fastener, they can be installed in places where you don't have access to the other side. Woohoo! If you're looking for a quality locker like we put in our Scout, then Eaton's Detroit locker is just the solution. This is Eaton's Detroit Truetrac differential locker. Truetrac is a helical gear-type limited slip differential. This provides automatic division of torque. Under normal driving conditions, Truetrac performs like an open differential. On wet, muddy, icy, or loose terrain, the imbalanced gear forces engage the locker and provide automatic traction to both your tires on your axle. So if you need to get the most torque and traction to your four wheels, then check out Eaton's Detroit locker.
When we come back, we're building a spare tire carrier for both our spares.
Hey guys, welcome back. Over the break, we decided to get our seats installed, and the installation was fairly straightforward. We made some bracketry out of thick plate steel and tied it all in with some angle iron. And we picked up these 5-point harness seats from summitracing.com.
And with the interior coming along nicely, it's time to move to the back half of the truck, because when we're out on the trails, we're definitely going to want to be carrying some spare tires. So we're going to build a spare tire carrier, because we're not going to only be hauling one, we're going to be hauling dos.
See.
The first piece, hopefully the tires will sit against this and it's actually going to tie cage together in the back a little bit too.
We chose a unique way of attaching this tube to our roll cage. We just put it in the notcher and cut halfway through it.
The Find center of the chassis, about 27. Half of that's about 13 and a half. So we'll mark it here. Put one there. And we'll put one there. All right. After a quick trip to the bender, this should hopefully be the piece that supports our tires above fuel cell. Now we'll put a tire up, see how it sits. All right, let's see. I stayed above the fuel cell. Perfect. About an inch or so. That'll work great. And hopefully this bar will keep the tires from falling out. All right, now with both spare tires in here, we know that they're not gonna roll out the back, but we gotta find a way to keep them from falling in on each other. So we're gonna have to add a couple pieces of bracing in between there, one in the front, hopefully tie this all together. All right, set this up. I'll try like 4 to 6 1/4. This bar will act as the front mount and will also provide extra strength in our cage. These bars will keep the tires from falling in on each other, and again, will add more strength to the cage. Make sure they sit about the same area, 9 inches to the center. Measure twice. That fits. Now we'll just add some braces that are going to run up and down to support the whole back loop. Throughout our entire build, we've been using the same material. This is 1 3/4 120 wall DOM tubing. These bars will help support the entire carrier from high G-force landings when we fall out of the sky. And on the other hand, we're also going to add some eyelets we made on our Edwards ironworker. These will allow us to strap down the tires and keep them from flying away when we launch into the sky. And we picked up these Y-type spare tire hold downs from summitracing.com. You're not going anywhere.
After the break, we'll get our digital gauge mounted at just the right angle. Stick around.
Hey guys, welcome back to XOR. We're getting ready to do the final install of our aluminum dash, and that means getting the cluster fitted in. We have chosen to go with RacePak's IQ3S. It's able to program up to 5 drivers' names, programmable shift and warning lights, 4 user-defined alarms such as temperature, RPM, oil pressure, and has gear indicator. The dash comes with the software and programming cable, and we've picked up their accessory kit to run all options. The main reason why we have chosen the IQ3S is because you can view vital functions easily and quickly. And it is also compatible with any of RacePak's VNet data logging, which means you can view all vital signs and driver behavior all in the same log. Okay, now that we have our seats in, we have a good idea of where our steering wheel is going to be. And I don't want to have the cluster in our line of sight, so that means we're going to move it down some. I don't want to ever have to leave our field of vision, so I'm going to go ahead and get this angled towards the driver. With the dash panel out of the Prerunner, the first thing I need to do is cut a slot out for the wiring harness to connect to the back of our gauges. A small sanding disc will take care of the burrs and sharp edges of our cut. Okay. Ooh, that looks good. All right, now to cut this out here so that we can bend along this line. We'll have it angled towards the driver. After smoothing the cuts, once again, I'm simply prying up my cutout panel to about a 30-degree angle. I think that's a go. I've cut out aluminum triangles to close off the top and the bottom. Since this is aluminum, I will be choosing to TIG weld this together. The TIG process gives me better heat control as well as has a cleaner look. For more information about anything you've seen on today's show, visit us at PowerNationTV.com. All right, there you have it. Dash in, gauges in. Now let's move on to more important things, like racing.
For those of you guys that may be running bigger wheels and tires on your truck, well, you're probably going to run into an instance when you need to change those bigger wheels when you're out on the trail. Well, we know that that stock jack that came with your truck isn't going to cut it. So we're going to show you a way to carry a bigger, more heavy-duty jack, and also show you a way to keep that jack from sinking in the mud or sinking in the sand. We're going to start by putting down some measurements on a piece of 16-gauge sheet metal. The piece we're going to use is about 23 inches by about 12.5 inches. And then we'll mark a 1-inch bend line and head over to the brake. Always bend just a little under, because you can always go more. And we're just going to weld this to a section of our Prerunner's cage. And now this is a great spot because it's right next to our spare tires. Now all I have to do is come up with a way to keep this from sinking in the mud or the sand. And this is how we're going to keep this from sinking into the sand. We're going to weld on a piece of aluminum onto the bottom to disperse the weight. And we made this the same way we made the carrier. Now all I have to do is prep this for welding. An angle grinder and a grinding disc quickly take the powder coating off the jack. Now this is an aluminum race jack, so we're simply going to TIG weld the plate on. Now we welded in a couple pieces of tubing to hold the handles in place. And when you set the jack down, that also keeps the handles from falling out. We also welded in some washers to help pull down the hold down.